All right, example 3. Given the functions f, g, h, m, and p, find these various things. Now here's the spicy meatballness about it. I have a relation given in ordered pairs. Ooh, what a spicy meatball pie is. I have a relation given as a graph, which I don't love that there aren't any arrowheads on. I'm going to fix that. We also have a relation in words. The output is twice the input. We have a relation expressed as an equation. And we have, last but not least, p of x expressed in a table of values. So what we're going to do is we're going to use the various forms that we see in front of us, and we're going to read them and give the proper, or give the not give the proper, just give the output. So let me just get back to writing here. So find f at 0. So what is being given here is always going to be our x value. So in an ordered pair, it's always going to go as x, comma, y. So if I look at x at 0, I'm going to say, okay, this is, the x is -2, no, 3, no, pi, 0. There we go. So when x equals 0, y equals 3. Simple enough. Just go like that. What about at f at -8? Do we have a -8 for our x? We don't. So we say undefined. Because when a function is given as an ordered pair, like that's it. It's this coordinate point, and this coordinate point, and this coordinate point, and this coordinate point, and that's it. So if you don't see a -8 in there, you can't have it. So what about p at 5? Well, if my x value is 5, that means that the p value, or the p of x, the output, what's being spit out, is going to be -4, and we can just read it off of the chart. What about g at -1? So remember, -1 is our x. So I'm going to go on my graph here and I'm going to say, okay, -1 is my x. What's my y? My y is 3. Now we're dealing with m. So m here says m at x equals 4. So m at 2 is 4, because there's no x to substitute in here. M at -5 is 4. M at cat, meow, is 4. So m at anything is simply 4. So m at 100 or -100, no problem. It's just going to be 4. It's a constant. If we were to graph it, it would be simply a horizontal line, because the y values are always going to be 4 no matter what your x values are. It's always going to be 4. So h at -15. So h here says the output is twice the input. So if this is what we put into the machine, and it's a magical doubling machine, that what gets spit out of it is twice the input. So 2 times -15 is going to be -30. Here's a bit of a tricky one. So this is what I was talking about, a little taste of grade 12. F at 0. So we figured out that f at 0 is 3. So instead of saying f at 0, I'm going to say, or like f at 0, I can just say f at 3. I'm going to use a highlighter here just to let you know that 3 is the exact same thing as f at 0. Now we are going to go into our function f and find out where the x value is 3. When the x value is 3, the y value is 7. So simply it is, or sorry, -7. So the answer is going to be -7. This is a two-step one, because first we need to figure out what f at 0 is, and f at 0 is 3. So then the next step is f at 3 is -7.